Okay, welcome to Unit 2, Lesson 7. This is Part 2 video. We left off here with Example 6. I wanted to see, well, actually, one of the reasons I left off here is I wanted you guys to try some of these on your own. And, we're going to pick up right now, and hopefully you tried them, and let's see if you got them right. Okay, so Example 6, write each of the following expressions in simplest form. Let's start with A. A. We have 16 to the negative 2.5. The first thing I'm going to do, okay, yes, I know you have a calculator. You can put it in a calculator. That's fine and dandy. But the first thing I'm going to do is I'm going to change that decimal to a fraction because I am very comfortable working with rational exponents or exponents that are fractions. So negative 2.5, that's the same thing as saying negative 5 halves. Okay, that's 2.5. So I'm going to change it. I got 16 to the negative 5 halves. Well, what do my exponent rules say? Well, first they say if I have a negative exponent, I need to flip it. Okay, so 1 over 16. Now my exponent is positive. And beyond that, top down, bottom out, right? So I have 1 over the square root of 16 to the power of 5. Top down, bottom out. Okay? And that's saying 1 over, well, the square root of 16 is 4. 4 to the power of 5, oh my God. 4 cubed is 64 times 4. Just for the sake of ease, let's do this in your calculator because we have one. Okay? 4 to the power of 5, is it 1,024? It is 1,024. Look at me. But it's always good, even though you think you may know it. You have a calculator. I have no hesitancy to check my work. Sometimes I have to. I like to. I like to be right. Why not? So ultimately, that's 1 over 1,024. There you go. That's the first one. Let's take a look at B here. B. Now that 2/3 applies to everything. Okay, everything inside of our parentheses, okay? So, my negative 8 gets a 2/3 exponent. My x next to it gets a 2/3 exponent. And that x and y have a square root. That square root, okay, I'm looking at this right here. This xy already has a square root to it. So technically, that's xy to the 1/2. Each one of those gets the 1/2. I'm raising that to the 2/3. Okay? And don't forget, if I have exponents raised to exponents, I multiply. So 1/2 times 2/3 ends up being 1/3. That's xy to the 1/3. Okay, so I'm going to say that 1/3 applies to both of them. It's x to the 1/3 and y to the 1/3. Okay, whew. You got to be good with numbers. You got to be quick. You got to be able to multiply fractions easily, and you should at this point. Okay, now I could take this a step further. Okay, this is the cubed root of negative 8 squared. Well, the cubed root of negative 8 is negative 2, and if I square negative 2, that's positive 4. All right? These two, this is actually nice. I'm multiplying everything. What happens when I multiply common bases? Don't I add their exponents? So right now my x's are common bases. So I'm going to add 2/3 and 1/3. That actually gives me x to the 3/3. Isn't 3 over 3 1? So that's like x to the 1. That simplified itself out beautifully. Love it. All right, and this last one, there's nothing I could do here except convert it. Okay, top down, bottom out. So I end up with, okay, so when everything's all said and done, it's kind of written how I want it anyways, but I'll write it a little bit nicer and neater. I have 4x on the outside times the cube root of y on the inside. Now, let me just say this. If you wanted to leave that as a fraction, the y exponent, because we're learning these things, okay? If this was short answer, you could say, yeah, that's a y. I'll save myself. 4x y to the 1/3, because this is the same thing as this. If this was short answer in the test, this is fine. But if it was multiple choice, just know if you end up what's here in red, multiple choice might be written like what is here in green. Just understand they're the same thing, okay? And you'll be all set. Last but not least, holy smokes. That last one was a little bit, detailed. I like it because there was a lot of little challenges inside it. You might be saying to yourself, yeah, you know what, Visca? That was just tough. Forget the little challenges. That's some bull. That was tough. Well, you know what? It was tough because it tested you on a couple different things, especially your rules for exponents and the operations. And you know what? That's exactly the type of problem that these Common Core tests throw at you. It's not just a math problem that tests you on one thing. Often, it tests you on 2 or 3 things that you should basically know, okay? So 6B, that was a good problem. I like it. All right. C, we have 16y to the -8th. All of it is raised to the -3/4. So my -3/4 is going to apply to everything in here, and 16 is to the power of 1. So I'm going to multiply. Okay, so I've got 16 to the -3/4, because 1 times -3/4 is -3/4. And then I've got y to the -8 times, or raised to the 3/4. So -8 times -3/4. Okay, 4 goes into 8 and -2. -2 times -3 is +6. All right? When I multiply -8 times a -3/4, I get a +6. So this is done. That's good. I've just got to simplify my thingamabob here, my number without the variable. All right, well, I know it's a negative exponent, so I'm going to put 1 over 16 to the 3/4. And I'm going to change that fraction exponent to a radical. So now I have 1 over top down, bottom out. Okay, and I still have my y to the 6. That just comes along for the ride. All right, well, I know I can do either one of these first. Let me explain this, and I really want you to pay attention in case you don't know this. I can take my radical and apply that first. Okay, so the 4th root of 16 and whatever that is, then I can cube it. Or I can cube 16 first, then whatever that is, I can take the 4th root of it. So you might be saying, well, what should I do? Do whatever's easier. If I have to cube 16, that's a very large number. I know the 4th root of 16 is actually 2. Okay? If I cube 2, I get 8. Now, if I were to cube 16, I'd get a large number. And if I take the 4th root of that large number, it would be 8. Okay? It would be the same. And now my y comes for the ride. There you go. That one wasn't as bad at all. All right? But I made a mistake. In all my glory of explaining what you should do first, either the 4th root or the 3, I forgot. Let me see, can I move this? There you go. I forgot. Damn, there you go. That my 8, it broke up the circles. It's on the bottom of a fraction, isn't it? It's not by itself. So technically, that 8 should be over 1. All I did, oh boy, see, this is why I look at these things. This equals 8. All right, that should be on the bottom of my fraction altogether, though. I wrote the denominator without a fraction. I wrote the 8 without a fraction. So I had to put my 1 over it, which I do. So it's 1/8 times y to the 6th. If I wanted to, I could also write it as y to the 6th over 8. Because this y to the 6th is technically over 1. And if I multiply them, that's what I would get. All right? Whew. Got to check your work. Okay, graphing radical functions. I'm going to do this problem and one more, and then I'm going to call it, end of notes. because I'm not too concerned about you graphing. On the final, you're going to have the graphing calculator, so I'm going to go over one or two of these just so that you know how to do them. But this one more specifically, I want to review that little after the -1. That's an inverse. I think we did that in Unit 1, oh, man, back of the day. But this first example says graph f of x equals x squared, and then graph f -1 of x, which is the inverse of x, on the same set of axes. State the domain and range of each. All right, so here we go. I should know at this point, if I'm graphing x squared, all right, I have my x's and my y's. I'm going to make a little table here. Bam. So we'll go from, I don't know, -3, -2, -1, 0, 1, 2, 3. I'm just squaring each one of these. 9, 4, 1, 0, 1, 4, 9. Let's plot these points. -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, that goes way up. I can't even plot these ones. They're not. I don't even have the room in the graph. Okay, so I'm just going to go from -2 to 4. -1 to 1, 0, 0, 1, 1, 2, 4. Okay, this is f of x, which is x squared. Okay, get in the habit of labeling these things, even if they don't tell you to label them. You know, I don't know. It just makes you look like you know what you're doing. Okay, now the inverse. There were two ways we could do the inverse. Okay, there were two ways we could do the inverse. The first one is if I have a table, I just flip my x and y's. Okay, so if I'm going to do f -1 of x, I literally flip my x and y. So I've got 4 -2 because I'm flipping this set. Okay, then I got 1 -1 because I'm flipping this set. Zeros 1, 1, 4, 2. Let's do it. Ready? Ready. So now that we have this table, let's plot these points, okay? I go to 4, 1, 2, 3, 4, -2. I go to 1, -1. I'm still at 0, 0. Still at +1. And then I go to 4, +2. So it kind of does this thing like this. And this is the inverse of x, okay? Now, there you go. We graphed them on the same set of axes. The domain and range, okay? The domain for my f of x, okay? I will do that in green. My domain for my f of x, all right? I can put in anything into my x. It goes left and right forever. So it's from -infinity to +infinity. My range are my y's. Notice it doesn't go any lower than the origin. So it goes to 0, it includes 0, and goes up to infinity. It goes up forever. Notice I have no negative y values for my green graph. Now, when it comes to domain and range of my inverse, okay, you're going to notice something here. My domain, my x values, it doesn't go any further left than the origin. There are no negative x's. So that goes from 0 to all the way to the right, +infinity. And my y's, as it goes to the right, it goes up and down forever. So that goes from -infinity, or excuse me, -infinity to +infinity. And just as a refresher, what did you notice? The domain and range of the original function, which is f of x, they switch to the inverse. Like my domain for the regular function becomes the range for the inverse. And the range for my original function becomes the domain for the inverse. They literally flip. Now, let me explain to you two things about inverses, just as a refresher, because we're doing this right now. If I had a graph, the easiest way to graph, to me, in my mind, to graph an inverse of a function if they give it to you, is the inverse. That's a reflection of the original function f of x over the line y equals x. So if I put a little line y equals x here, okay, that's this line right here, okay? If you had to visually tell whether something's an inverse or not, you should notice, okay, this point right here is a reflection right here. This point is a reflection of the line itself. This point goes 1, 2, 3, 1, 2, 3, right here. So every point, 1, 1, is a reflection. Okay, it's a perfect reflection. That's how you know it's an inverse. All right? And how would we do this algebraically? If they want us to algebraically find the inverse. Okay? Again, these aren't in the notes. These are just refreshers. If I have y equals x squared, and I want the inverse, find y negative 1. Just like the table, I switch x and y. So I have x equals y squared. I literally, quite literally, switched my y and my x. Not the exponent, just the letters, the variables. Okay? And now I solve for y again. So don't I do this, and don't I do this? So y would equal the square root of x, but don't forget, plus or minus. Okay? And that's how you get the top part, the positive version, and the negative version will be the bottom part of our graph. And that's exactly what we have up here in red. Okay? Good. Good. Let's do one more, and we'll call it over. All right, the easiest way, example, graph y equals x plus 2 to the 1/2 minus 3. If this were an exam and they wanted you to graph this, okay, you have your calculator. In order to graph something, okay, you want some coordinates. You want to plot some coordinates, so you want to go to the table. Now, I teach Algebra 2 Regents. I teach pre-calculus. I teach calculus. I had a Proctor in Algebra 1 exam, and there was a good handful of kids that they had to graph something, and they weren't even reaching for their calculator to put it into y1 and to look at that table. Now, maybe they were just trying to algebraically put in an x and find a y, but, I mean, I'm thinking at this point, you guys can algebraically do that if you didn't have a calculator, like if you're at home, you don't have a graphing calculator. But when you're at school, if you got one, if it's final exam and you have one, I would definitely plug it into y1 and get that table. So that's exactly what I'm going to do. I'm going to clear this out. And I'm going to type it in exactly as it's presented to me. Parenthesis, x plus 2 raised to the 1/2. Okay, pop off there, minus 3. And if I look at this table, all right, look at this table. How far do I go? 1, 2, 3, 4, 5. It's 6 by 6. So, ooh, look at us go. All right, let's get some points. Ooh, 7 is at 0. Thank you for this lovely graph. So I'm going to go back up here. 3, you'll see, once I hit 3, negative 3 rather, I get an error. And how come? Don't forget, this 1/2 is the same thing as saying the square root of x plus 2. I cannot have negative numbers underneath the radical sign. So the moment that my x is bigger than negative 2, this will not work. Okay? So, let's take a look at our table again. Let's do this. Bam. And we'll do something like this. All right? In fact, let's get a few more. We know anything beyond negative 3 isn't going to be good, so one more up. I'll be okay. It's been a long morning, kids. All right, I'm going to put this one out here. Let's get this right here. Now, I don't plot anything at negative 3. At negative 2, I go to negative 3. So go to the left 2, down 3. Right there. Here, negative 1, negative 2. That's right there. 0, let's call it about 1.5. So it's 0, I'm at negative 1.5, right around there. Okay, at 1, I'm negative 1.25 almost, right around there. At 2, I'm right at negative 1. At 3, I'm at negative 3/4. And at 7, remember we saw 7 was 0. 7 is right about here. Okay, 1, 2, 3, 4, 5, 6, 7. That's right at 0. And it's going to do this and kind of just keep on going that way and slowly rising up. All right? That's what it looks like. Any sort of square root or whatever, it's going to look like this. Remember, the minus 3 in the back means it just dropped 3. Okay? Let's talk about movement another as a review again. If I graph y equals radical x, that looks like this, okay? It looks something like this. But once I say x plus 2 minus 3, this means I'm moving down 3, and inside it's the opposite. I'm moving left 2. So if I take this bad boy, let's turn it into a cloner. Let's see what happens. Is there an infinite cloner? There is, but there it is. Bam. If I take this, I move down 2, 1, 2. I'm sorry, 3, and move over 2, 1, 2. Look at that. Bam. Okay. Again, our movements. Down 3, over 2. Bam. I'll do this again. Down 3, over 2. Is it up 3? So whatever I do, no matter what these things are, if I moved right 2 and up 3, that's what it would look like. Okay, so this thing, bang, just keep on sending them. Keep on sending them. Love the infinite cloner. Love the infinite cloner. It's the best thing ever. That'll bounce. All right, we are done. We are good. We are fantastic. I'll see you for Unit 2, Lesson 8 sometime in the near future. See you then.